Dr. Aditi Mittal is a new entrant in the field of hematology from the profile that I see on the screen. She did her MD pathology from Sri Ram Institute, medical college in Bareilly, and completed her fellowship in hematopathology from B.L. Kapoor, obviously with Dr. Handu. She has done publications in national and international journals, which will happen when you work with people like Dr. Handu, of course, but not to take away any credit from you. And she is a member of Delhi Society of Hematology and the Cytometry Society of India. And she is currently working as associate consultant in hematology at B.L. Kapoor, Max Super Specialty Hospital in New Delhi. Aditi, welcome, and we look forward to hearing from you something new. I don't see the subject of your presentation, but a topic, comparison of platelet count on hematology analyzers and digital morphology.
Yeah.
A very exciting prospect here, and look forward to hearing you.
Thank you, sir, for the introduction. I would like to thank to my mentors, Dr. Anil Handu sir and Dr. Tina ma'am, to give me this opportunity to bring forth my research in front of everyone. So I am talking about the correlation of platelet count by optical and impedance method on Mindray BC 6800 plus and the platelet count by digital morphology. So platelet count has always been a controversy among all the doctors, and because the patient management depends on the platelet count, and we want to give the platelet count as accurate as possible, as quick as possible. So the assessment of platelet count is essential in both clinical hematology and platelet research laboratories, and any numerical deficiency or defect in their function may lead to bleeding. So in severely thrombocytopenic patients, the accuracy of the platelet count is of utmost importance, as the count is used to determine if the patient requires platelet transfusion. Especially in the dengue time, it becomes very essential. So they need no introduction. They brought a revolution in the blood counting by giving Coulter principle to us, and later platelet count were added to the automated blood count in late 1970s. But till now, we have come so far, and ICSH first gave phase contrast microscopy as a standard for platelet counting. Later on in 2001, it suggested flow cytometric platelet counting as the reference method using RBC and platelet ratio by using CD41 and CD61 antibodies to identify the platelets. So, but it has its own limitations because it is an expensive test, labor intensive and time consuming, and requires a skilled person. So not every laboratory can afford to apply flow cytometry counting for the platelet count in every case. And there are other techniques of the platelet counting, like direct methods by hemocytometry and microscopy, indirect methods in which red cells were counted directly and their proportion to platelets determined in a stained blood film. Semi-automated methods in which counts are performed electronically using PRP, and fully automated methods. These today automated analyzers have come, and they make this platelet counting little easier by using following methods: impedance method, optical fluorescence method, and the immunological method. Not going into detail of them, I think everyone knows about them. But still, we still get a call that yesterday you gave the platelet count of 250,000 and today's the platelet is just 14,000. Can you give us a manual platelet count? Or you can confirm the platelet count is 10,000, is it really 10,000? Can you confirm it by smear? So we still rely on our blood examination manually on the stained smear, and it is very useful, especially when the platelet counts are spuriously low in cases of EDTA-induced platelet clumping or platelet satellitism. Also, it also helps to detect abnormal morphology of platelets, which can indicate to certain diseases like small platelets in Wiskott-Eldridge syndrome, or large platelets in some chronic myeloproliferative disease and Bernard-Solier syndrome and macrothrombocytopenic cases. So the aim and objective of my study is to correlate the platelet count by these methods, optical and impedance, and correlate it with digital morphology and manual smear count. So we took 1,000 patient samples, both IPD and OPD, and from June 2023 to August 2023, and the age range was 2 to 80 years with no significant male to female preponderance. And platelets were analyzed in Mindray BC 6800 plus. Both impedance and optical modes were run, which is CD and CDR modes, were run on the analyzer. And then we have auto stainer of Mindray SC120, and the slides were stained in it. And the manual smear counting was done. And then the sample was also run on the digital morphology analyzer, Mindray MC80, and also platelet count was determined through the digital morphology. Here we used manual smear counting as our gold standard because we can't put, because of the cost strains. So we took manual smear platelet count as our gold standard and compare it with each of those methods. So the microscope used was Nikon microscope 80i, and the platelet estimate factor was used for 10,000. So how did we calculate this factor? So we take 1,000 cases of unflecked normal platelet count, and then smears were processed in Mindray BC 6800 plus and stained by Mindray SC120, and number of platelets in each oil immersion field for each case was determined. And then flow cyt, although we did flow cytometry in few cases, like 20 cases, and correlate with the manual smear count as well, and based on which average number of platelets were calculated and our factor was determined. So the analyzer used in the study was Mindray BC 6800 plus, in which CD and CDR modes were run on each sample, and we got impedance and optical platelet count. This is a SC120 slide maker stainer. It can stain up to 180 slides per hour. So it's also time saving. And the blood volume, according to the hematocrit of the volume, it can adjust the spread of the smear, and the protocol used at our center is Right Jinsa. And the sample volume taken by this 200 microliter. Then a new advancement in technology has coming these days, and digital morphology has changed and make it more convenient for us to give the platelet count as quick as possible. So this is Mindray MC80 analyzer workflow, and it take almost 5 million photos of all WBCs, and almost take 3,500 scan 3,500 fields and give us 2D images, and on the basis of it, suppose this is an example that I run a sample, and we get WBC. It automatically divides the counts in WBC, RBC, and platelet. And in WBC chamber, it gives like this, and RBC it gives images and segregates them in different. And in platelet, there are two modes. So in auto mode, this digital morphology analyzer counts automatically by itself, and it gives us the count. For example, in this case, the platelet count was by impedance method was 1,02,000, and platelet clump was flecked. So I also looked at the smear, and I found no clumps, and the platelet count was almost 1,40,000. Digital morphology analyzer in auto mode gives 1,38,000. Then it also give you the way to manually count on the images by yourself. So there is a manual mode, and you can count the platelets in each image, the boxes given below, and based on that, it automatically calculates the platelet count. So after manual counting on digital morphology, it was 1,42,000. However, no clump was flecked. So in our study, we took the samples with platelet flecks. We include the samples with platelet flecks like thrombocytopenia or platelet histogram abnormal, platelet clumps, or R-fleck for review. But for platelet, especially in case of platelet clumps, there is a mode in the digital morphology analyzer, which is pro-platelet mode. So like in that case in which the clump was flagged, and I got 1,42,000 on digital manual mode and auto mode 1,38,000. The sample was run in pro-platelet mode as well. It uses its high magnification optic lens to scan the body edges and tail of the smear to locate and identify the platelet clumps. And this is how it looks. So it detects 4 tiny platelet clumps in the platelet pro mode, which could be missed, which was missed while during the manual smear examination under the microscope. So in our study, we compared all the methods with like automated method by digital morphology, manual count by digital morphology, impedance method, optical method, manual smear count, and flagging versus pro-platelet mode. And we calculate the mean by every count, every method, and calculated the mean, and we found that if compared to manual smear count, the average mean of optical, average mean of manual digital count was closer to the manual smear count, followed by the optical method, and then automated digital method. And impedance has the least correlation with the manual smear examination. Then we also calculated the Pearson coefficient for each method. So in automated digital versus manual, if we see the graphs, there were not so much outliers. If we see the graph, and the Pearson coefficient was 0.95. For manual digital versus manual manual smear count was Pearson coefficient was 0.97. Then impedance versus manual, Pearson coefficient was 0.94, and optical versus manual, Pearson coefficient was 0.98. So when we tabulate that data, we found that manual digital was there was the best correlation between the manual digital method, manual count by digital morphology, and manual smear examination, and under the microscope, followed by I think optical method, which was 0.98. So they were the closest, which were to the manual smear counting, and impedance has the least correlation with the manual smear counting. Then we also calculated, we also compared the pro-platelet mode with flagging of platelet clump. So all the 1,000 samples, we found that pro-platelet, when the sample was run in pro-platelet mode, the sensitivity and accuracy has increased from 92.6% to 100% and 90 to 92% respectively in pro-platelet mode. So this might be a clue that pro-platelet mode has better sensitivity, is a better way in the coming time to detect the platelet clumps. Also, there were 3 outliers in which the 2 of the cases there was no flagging. However, both manual smear examination and digital morphology pro-platelet count detects the platelet clumps. And in one case, there was neither flagging or no platelet clumps detected in the manual smear examination. However, pro-platelet mode in Mindray MC80 analyzer detected 2 platelet clumps. So again, it is indicating that pro mode is a better way of detecting platelet clumps on digital morphology than smear examination, and it is well correlated with the flagging given by the analyzer. Also, there was only one study in the literature, which the use of Mindray MC80 digital morphology analyzers estimated platelet count, and they also found the similar results as us. And so to conclude, that optical method is the most accurate method of the platelet counting when correlated with manual smear platelet examination. So simultaneous measurement of platelet count by optical and the smear examination can give us the more accurate platelet count results, followed by digital morphology can make it easier and less time consuming because it takes time to stain a slide, and digital morphology scans a slide in just 1 minute, and the staining time by the auto stainer is just 15 minutes. So in 15-16 minutes you can calculate the platelet count, and it is almost as accurate as manual smear examination under the microscope. And impedance has the least correlation with the manual smear platelet examination, and pro-platelet mode has definitely the higher sensitivity and accuracy of detecting platelet clumps. Thank you.
Thank you, Dr. Mittal, for bringing out a very important message. And I just had a clarification from you. See, I would like to seek a clarification. And that is when you are talking about manual platelet counting, you are talking about platelets with respect to the RBCs. What is your
I'm
on the smear?
manual smear count, manual smear count.
No. So how are you counting? I mean,
So
with
I am
respect to what
counting.
is your benchmark?
So I'm counting 10 fields, platelet counting platelets in 10 fields, and the platelet estimate factor for our microscope was 10,000. And so, like in one field, whatever the platelets are
Yeah.
counting is multiplied by
Yeah. So
10,000.
over impressed by the accuracy of that manual way of counting because we know it has its own limitation. It is not a actual enumeration of the
Yes, sir. So that's why we did flow cytometry counting also in just 20 cases, because we can't do because of the cost strains in all the cases, and try to see that almost as same as the manual counting. And in usually routine practices, we rely on our manual platelet count only.
That's true, but that is somewhat like an estimate. It is not a
Yes.
true count. And therefore, as I said, I'm impressed by the correlation you're finding with the optical platelet count and the manual, digital or actually manually done. So that is just an observation, and if that's the case, then I think manual counting would replace, in many labs, platelet counting by even the analyzers. So there's something to ponder about. I mean, just an observation, but it's a very beautiful presentation, very good work, and I think there would be some more comments.
Thank you, sir.
Aditi, very good, well presented and thought about.
Thank
But
you.
when we talk of manual platelet count,
Yes.
we were talking of the old gold standard, which the
Phase
International
contrast.
Society had taken.
Yeah.
The Brecker's method, which is 1% ammonium oxalate.
Yes.
And doing the chamber count.
Yeah.
Yeah.
Sir.
And this method, what you are describing on a smear,
Yeah.
is on a EDTA smear.
Yeah, yes.
It cannot be done on a fresh smear, first thing.
Yes.
And we know that EDTA smears have little bit of fallacy of EDTA clumping.
Yes, sir.
So you have to see that your analyzer has not given you a flag of clumping.
That's why the pro-platelet mode is there.
Yes, and only in those cases you can compare your slide count with your other count.
So we ran pro-platelet mode in every case.
Yeah.
And we also saw the slide for clumps in every case under the microscope, and also on the pro-platelet mode on digital morphology.
Yeah, because Brecker's method using 1% ammonium oxalate can be very tedious, cannot be done practically, but yes, very high CV, but still in our lab, when we are comparing or actually confirming the lower counts, we are doing morphology with manual Brecker's method as well. But good, because you have to be little careful when you're giving a slide count. I know, and it has to be counted in an area where there is just no overlapping of RBC.
So the pro-platelet mode, it scans the slide towards the tail and the edges of the smear only, so that no clump, because clumps mostly found on that area.
Yes.
So it almost scans various fields to give us that there should be no clump left, or if there are any clump, it highlights it.
Very good.
Yeah. Thank you.
Nice, saves time. Yeah.
Just one short comment on the flow-based assay.
Yes.
Some of us who have worked in that area will tell you that the assay doesn't take care of the issue of platelet aggregates. Yes. It is blind to that. And in flow cytometer, aggregates would tend to get excluded once you put the gate, because they assume different size and granularity. And therefore the count, although it is touted to be a very accurate count and gold standard method and all that stuff, but people who have actually worked with this method will tell you it is not so rosy as people tend to project it to be. And as you rightly mentioned, others have also mentioned, that it's not a very practical way of doing the count on a day-to-day basis, because it's also expensive. So just share, I was thinking of sharing this thought with you and for the general audience. Yeah, sure.
When you were doing the manual counts, what were the areas that you were actually doing? Like ma'am said, the selection of the area where you
towards the
see
tail where the RBC are just lying,
the tail is a
sitting
very
next to
big
each other,
area.
not overlapping
Plus
it.
smears, when you make, every smear is different. I mean, no two smears will be similar and no two smears will have similar kind of area. So there's a lot of manual variation
The
in making of
smears
smears.
on which we did the platelet counting was stained by Mindray analyzer, auto stainer.
That you're talking of the analyzer stainer, but your manual count when you're
That
doing
was done on that stained
stainer
smear. So
only.
they were
Okay.
evenly spread.
Okay.
All the slides were evenly spread by
Okay.
the auto stainer. That's again an advantage of the auto stainer, that according to the hematocrit, it automatically adjusts that angle and evenly spread the slide. So that was
because I think there is a difference between what manually we are doing. I think the
the manual smear count was done on stained smears, on the smear stained by auto stainer.
On manual made smears, I think we have the count factor of 15,000. That's where I think I differ with or maybe the selection of the areas is different with
because this estimate factor is based on the microscope we use, on which we counted the platelet in the microscope at Nikon ATI, and it was 10,000 for our microscope.
Okay. In our here, I think we use 15,000 as a.
Thank you. Yes. Thank you, Asim. I think we'll stop here.
Actually, I just wanted to clarify that point of it, what you were telling us, ma'am.
Yeah.
When you decide what is the factor that you will have for your laboratory, it's heavily dependent upon the area of your microscope and the way the smears are made. So if I have 10,000 in my lab, it is not necessary that in your microscope, in your lab, it will be 10. There it might be 12 or maybe 20. And maybe in somebody else's lab, it might be about 8,000 or 7,000. So it will be variable. That's why when we decided to determine the factor, the idea was take the benchmark. What is your benchmark? Benchmark is flow cytometry. So do flow cytometry on 20 samples, get your platelet counts from there, compare the counts which have come from the hematology analyzer, look on the smears which has been defined, designed and developed on the auto analyzer, not by you by hand, so that there is some degree of uniformity. And then when you take the ideal zone, figure out in that ideal, so-called ideal zone, as to how many platelet points did you get. And then basis that gave you some degree of standardization. Of course, when you're going to be doing things manually, just as the way what we're talking, the CV is definitely going to be higher. We're not talking about flow cytometry here. We're talking about something which will have probably a CV of maybe 10, 15, 20%. But with that part of it also, if you take it, in any case, as a routine, if you look at hematology analyzers, how do you verify your counts when you are running the samples on a CBC analyzer? You verify them by looking on a smear at the end and just checking out, grossly. That, okay, the platelet count might be about 1 lakh, or this platelet count doesn't look like 1 lakh when you're comparing it with the impedance. So keeping that in mind, we looked at this study and thought, let's see what digital morphology tells us, and how does digital morphology come up and give us the pickup of all those clumps which we may otherwise miss even when we are seeing a smear. So that's where pro-platelet mode seemed to give us a better result. This was more of an observational thing. We will be expanding it further and trying to see with respect to the standard methodology, and we'll come back to you with that.
Yeah, so it is too impressive, Anil, comparing manual and finding such an excellent correlation with the automated counting. That is something which is, if proven through a larger study, is a very important information. So, okay, so I think we'll stop here. I think we have had a lot of discussion on platelets every day, almost in all sessions, but these are all very enlightening discussions, because on one side, it is also very satisfying and gratifying to learn that we are progressing, forward in the ways of doing better counting. At the same time, highlight the challenges that we still face or are remaining to be addressed. So I think
And
that's
it
an
also
excellent-
gives you an option to convert all the images into PDF. So if you are not in the lab, your technician can send you the
Right.
whole
Yeah,
PDF of the
yeah,
picture
those
and you can
advantages
see
are
it from there.
Yeah, 100%. Okay, thank you. I think we'll stop here. We'll have to stop here today.
It's just to comment that the MC80 have a special mode that can check for the edges and the borders to check for platelet clumps. If the platelets are less than 150, you can check a special mode that check the edges for looking for the platelet clumps, because I agree, some samples don't have a clear pseudothrombocitopenia, but have some small clumps. And this is the reason it was created, this software for that.
It's a new development. Yes, thank you. Shama?
So,
Thank
you,
Session.
sir.
Thank you all very much.